So we are in 5.1. We're going to start this chapter on identities. It's called Verifying Trig Identities. It starts on page 586. So if you want to turn to it and kind of keep up with it. There on page 586, they actually go ahead and remind you of the fundamental trig identities that you're supposed to already have memorized. When I do something up here, most of the time, anytime I change something or the way that it looks, is because I used one of these identities. So if you have this firmly in mind, then you'll kind of know what I'm doing. Example 1, or checkpoint 1, we'll call them checkpoint 1, says verify the identity that the cosecant of x times the tangent of x is actually equal to the secant of x. Now, what you are doing when you verify the identity is you're doing algebraic or trigonometric manipulations with one side of the equation to make it look like the other side. And so the rule of thumb is always you take the side that's more complicated looking and try to make it more simple, because it's harder to build up than it is to kind of squish things together. So one of the things that I do when I have cosecant and tangent and secant is that I start out by using the identities that are the reciprocal identities and the quotient identities. Remember that the cosecant is the same thing as 1 over the sine of x, right? And the tangent is the sine of x divided by the cosine of x. And we're trying to make that look like the secant of x. And we're not quite there yet, right? So a lot of times I turn everything into sine and cosine. Now, if I have the sines that thank you so much. Okay, if I have these things that are multiplied together and one thing's on the top and one thing's on the bottom, what do I know about that? They cancel each other out or reduce out to ones, right? So if I reduce those, they divide out to 1, and I'm left with 1 over the cosine. Now, what is 1 over the cosine? It's the secant. So once you have both sides looking the same, you can put a check or you can put your smiley face or whatever you want to do, because that says that you're through with that problem. When I make both sides look exactly the same, you're finished. That's verifying the identity. It says that you have just proven, using algebra and trig identities, that this is actually equal to this. Now, yep, that's all it is. Let me point out that you do not want to be like adding and subtracting things from one side to the other. Don't be pulling things across the equal sign, and you do not want to work on one side for a while and then work on the other side for a while, because then you miss, like you're trying to meet in the middle and you miss each other because you went by different roads. Because remember, we've talked about in here about the fact that there's lots of times there's more than one way to do it correctly. And so if I've taken the path with this one and I've taken a different path with this one, I may never actually meet in the middle, although I'm doing good things on both sides. So just work on one side at a time. Work on one side till you can't think of anything else to do. Then if you have to, you can go to the other side and work on it. Most of the time you can just work on one side and turn it into the other. Any questions about that? Okay, there is a study tip there on page 588 that you might want to look at. It's just kind of a FYI, something to think about. But they remind you that verifying the equation as an identity is different than solving. Okay, you're not solving it, you're verifying it. Okay, so you might want to read that study tip on page 588 at the top. Next example, check point 2. We're going to verify this identity that the cosine of x times the cotangent of x plus the sine of x is equal to the cosecant of x. So what's your guess on which one I'm going to work on? The long one, right? The left. All right. So what do I have here that I can work with? If I'm going to use my idea that I used last time about changing things into sines and cosines. No, not yet. I'm working on the left side, remember? The cotangent is the cosine over the sine. Good. Okay, so this is the cosine of x over 1 if I want to make them both fractions, right? Times the cosine of x over the sine of x plus the sine of x. So what does this become? The cosine squared of x over the sine of x, right? So I just multiply top, and the bottom times the bottom. Plus the sine of x, and that is over 1, right? Now, what do I need to do? Remember, I'm trying to simplify this one side. I don't want it to have two different things, two different fractions. So how do I take two fractions and make it one fraction when I've got an addition between them? Has to have the least common denominator. What is my common denominator in this case? The sine of x. So the first term, cosine squared of x over the sine of x, is fine. But what do I have to do to this second one? Make it sine squared of x over the sine of x, because I need to multiply the top and the bottom both by that sine of x. Now that I have the same denominator, what can I do? Just put them together, right? So I've got the cosine squared of x plus the sine squared of x over the sine of x. And that's still equal to that little cosecant of x we've been carrying around. Now, what did I tell you about sine of x, sine squared plus the cosine squared? It is 1. We love that identity because it makes things look so much nicer. That just the top all becomes 1. And it's still over the sine of x. And what is 1 over the sine of x? The cosecant of x. Okay? Any questions? All right. Well, I hope not. Okay. Checkpoint 3. We've got the sine of x minus the sine of x times the cosine squared of x is equal to the third power of sine of x. Okay? Again, which side do I probably want to work with? The long one, the left side. Now, do you see anything in there that you would think about that you could do? Because I can't turn everything into sine and cosines because it's already sines and cosines, right? So what can I do, though? How many terms do you have over here? Nope, I got 2. This one and that big long one right there. In those 2 terms right there, is there something that's the same? Okay, they both have a sign in them, right? If I have 2 terms and they both have the same thing, what can I do with that? Factor it out. So I'm going to factor out the sine of x. Now, what's left in the first term when I factor out sine of x? 1. And there's my minus sign. And then what's left in the second term? Cosine squared of x. Now, if sine squared plus the cosine squared is equal to 1, what is 1 minus the cosine squared? Sine squared, right? Does everybody understand that? If the sine squared of x plus the cosine squared of x is equal to 1, then if I subtract cosine squared of x from both sides, what does that leave over there? Sine squared of x is equal to 1 minus the cosine. Okay? So I can replace 1 minus the cosine squared with the sine squared. And what is the sine of x times the sine squared of x? The sine cubed of x, right? And guess what? We're done. Okay. All right. So sometimes you will have to factor to be able to do these. Never. No. Might happen on your homework paper, buddy. They are all supposed to do this. All right, so I've got 1 plus the cosine of theta divided by the sine of theta is equal to the cosecant of theta plus the cotangent of theta. What side are we going to work with? They're both a little bit big there, so we're going to work with the fraction side. All right, so we're going to work with the left side again. So if I have just one denominator on the bottom and more than one thing at the top, then I do have the right not only to pull it together, but I can also take it apart. And this has got 2 terms, so it might be that I need to take it apart. Always look to see where you're going before you just start doing stuff. It'll cut down on those number of times when you wander down the wrong pathway. So if I pull that apart, that becomes 1 over the sine of theta plus the cosine of theta over the sine of theta. What is 1 over the sine of theta? The cosecant. And what is cosine over the sine? The cotangent. What else do we need to do? Nothing. We are finished. All right? I don't know. All right. Got it?